Well, good afternoon. Welcome. Welcome. It's nice to have you here. My name is Miss Pat. This is Miss Diane, and we are both science teachers at the SciTech Museum in Aurora. And today we're here to talk about weather. What do you know about weather? What do you know? Please raise your hand and wait to be called on. Climate, we have climate change, yes.
Weather can be really strong.
It can be. Winds can be strong. Temperature can be low.
Low,
High.
and zero.
It can. What else? What else do you know? Yeah.
There's a variety of different weathers.
Yes.
There is.
Weather is constantly changing. What's the one thing that controls all of our weather?
God, Jesus,
Keep coming, bring it down a little bit.
wind.
What controls the wind?
Well, or the earth. Cloud.
Begins our weather system.
Hey, please raise your hand. Yes. Keep going. The sun. The sun directs all of our weather. So today we're going to talk about, we'll start talking about heat and light. May I have someone volunteer who has lots of hot air? You have a lot of hot air? Come on up. All right. And I'm going to ask you to stand here, put your hands behind your back, and you're going to blow and make that turn. Okay? All right. Start blowing. Okay. Tell me when you're ready to blow. Oh. Keep blowing. Now mine is moving, but yours isn't. Okay, you can stop. Why is mine moving? You may sit down, thank you. Why is mine moving and hers is not? Why?
This is stronger.
What's stronger?
The
Now, she was blowing. Was the air impacting it? Was it affecting it? The heat was. The heat, the light was impacting it. This is the model, a model of a radiometer. And a radiometer is a weather instrument that measures heat energy. And you might see these, something like this, you'll see the black and white, up on top of a building, okay, where weather forecasters use a radiometer to measure heat energy. Could I ask, would you please come and stand up a moment? Would you come up here? And would you please stand up? Come on over here. Now, take a look at the color of their shirts. Which one are you more likely to see in the summer? What color? Don't think fabric, think color. Guess.
The
Which?
white one.
The white one. Why?
Because the sun heat goes on the darker colors.
Okay, and what does it do on lighter colors? It reflects. It reflects or bounces off to keep you cool. As opposed to in the winter, we wear darker colors because the heat is, it's attracted or absorbed. Thank you so very much. So, just as we talked about the light and dark, the white, on one side the white is reflecting, on the other side of the panel the black is absorbing it, and that's what makes the radiometer go around.
Now, the sun's energy is going all directions, but what comes down to our earth is what interacts on the earth. And we have something that's in the earth's atmosphere all around us. What is it? Oxygen, air, gas, whatever one, sure. And, yes. Well, that is a specific place in a volcano, yes. But I'm talking about all around us here. And air has a pressure of its own. The air can be very heavy. There used to be a saying that it felt like an elephant sitting on your chest. You know, on those hot, humid days in the summer, when everybody heads for the air conditioning, that air pressure is very heavy sitting on you. Well, we're gonna show you a couple of things about air pressure. Now, I've got air in the middle here, air on the outside, right? I'm gonna put these two suction cups together. These actually are called dent holders, because you can pull dents out of your car with them. But we pushed all the air out of the middle. Now I need 2 volunteers who have not been up here. 1, have you been up here? Okay, 2. And I want you to pull straight back and try to pull these right. Step over here. What's happening? Are you pulling? Yeah, it's stronger than you are, isn't it? By pushing all that air out, the air pressure is on the outside. Now, if you hold them, and this time, twist them. You twist this way, she twists that. Wasn't that a lot easier? What happened when you twisted it?
More air started to come in.
Right, and it broke that pressure that was built on the outside, and the air could come back in. Okay, now Ms. Pat's going to show you something more about air pressure.
All right, when we talk about air, okay, what's in this beaker?
Air.
Air?
Oh, I'm proud of you guys. Nobody said nothing.
Yeah, no one said that. How do you know?
Because air's everywhere. Air is everywhere, so it has to be in there.
But maybe somebody wasn't telling you the truth. How do you know? Just because someone said you believe what everything everyone tells you?
Air is everywhere on Earth.
Everywhere on Earth? Okay. Do we have a way to show that there's air in this beaker? Do we have a way to prove it? You say air is everywhere on the Earth. Okay, how could we prove it?
By putting your hand in it. Air is so light you can't even feel it.
Okay,
But it can be everywhere.
you can feel it. Okay, may I have a volunteer. Volunteer, please, come up. All right. I have paper towel. Is it wet or dry?
Dry.
It's dry. Okay. We're going to fold this up. And we're going to put it into our beaker. Now my volunteer and I are going to turn this upside down, and we're going to put it into this beaker of water. You ready?
Thumb up if you think that cloth's going to come out white. Thumb down if you think it's going to come out green. Everybody's thumb.
White, green. White, green. Make a decision. And remember, it's okay to be wrong. Scientists are wrong all the time.
You make a hypothesis and then you test.
Okay, we are pushing it down. Okay, we have it all the way under. Step back so they can see. You see that it's under the water?
Yeah.
Everybody? Okay, let's take it out. Wet or dry?
Dry.
It's dry. It's dry. Magic?
No.
No. Science. Tell me,
What?
why? Why is it dry? Say it again. The air pushed the water away. When we put it into the water, there's air in here. Air has mass. It's made of stuff, all right? It takes up space. So when we pushed it into the water, the air would not allow the water to go in and kept our paper towel dry. So in this way, we can show that air has mass and takes up space. Thank you so much.
All right, we've talked about the sun's energy We've talked about air pressure. Now we're going to go to the water cycle. Have you heard of that before? Okay, stand up. Everybody. Okay, up in the sky, there's little water droplets. They all grab a little piece of dirt and they start coming together. They hook together and we call that clouds. Condensation. Condensation. Okay, they get really heavy.
And then they start falling.
Rain or hail or
Snow.
or sleet. Right, rain, snow, hail, sleet. Coming down. And what do we call that when it's something coming down? Precipitation. Now it goes into lakes and rivers and we call that collection. Or sometimes you'll walk outside in the morning and it hasn't rained, but the grass is wet and the trees are wet because there's moisture coming out of them and call that transpiration. The dew is the moisture on the grass, you're right. But we call that process the transpiration. Then out of the lakes and rivers it starts coming back up and then we call that evaporation. Right, so it goes down and it comes up.
So it's like
It
transporting.
goes down and it comes up. Do we get new water?
Yeah.
There's no new water. It just goes down and it comes up. And it goes down and it comes up. So do you know what that means? You're drinking the same water the dinosaurs drank. Think about that.
That's true, actually.
It is true.
It is true.
I remember
Go ahead and
the
sit
book.
back down.
I remember in the book that.
Now, before we ask you to do the next thing, I need somebody who's strong enough to do this fast and steadily for 35 times. Have you been up here yet? Come on up. We're going to go to that side of the table so everybody can watch it. And the rest of you will get a chance later when we're at the tables with stations. Good? Now, the air pressure outside is the same as the air pressure inside because that air can flow in and out. She's going to put more air in there, pumping up more and more air. It's going to get really crowded and really hot in here. And then when we let the cork go, that air is going to rush out, and when it rushes out, it will cool down, and it'll bring some of that liquid with it and create a cloud. It's real condensation. So fast and hard as you can. 2, 3, 4, 5, 6, 7, 8, 9. Count with it. 10, 11, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. It's starting to get hard. Okay, let's pop it. Very good cloud. It's coming out the top. Go ahead and touch your cloud. You've touched a cloud. And that is condensation. It's a real cloud.
What are you made of mostly?
Water.
Water. How much of your body is made of water? Do you have any idea? Close. Very good. Very good. Somewhere, scientists
50.
say somewhere between 80 and 88% of your body is water. Now, being made of that much water, you are one big bag of water. Having that much water in your body, do you carry electricity? Thumbs up, yes. Thumbs down, no. Sideways, not so sure. Okay. You got a thumb? Good. All right. I need a volunteer who has not been up. Please come up. And have you been up yet? Please come up. All right. And would you please face each other? Okay. Have you seen these?
Mm-hmm.
No? Okay. If you have not, these are called, this is probably my favorite science toy.
We're just
This is called an energy stick. Energy stick. We sell these at the museum, but you can we buy this ours from the Steve Spankler website. I really like his website because he has free experiments on his website, so check it out. Now, I'm going to ask you to take this hand and your inside hand there and touch finger to finger. Okay? Keep touching. Now, I'm going to ask you to hold this tight and you hold the other end. Now, what's happened is because they are made of water, they are conductors of electricity. Energy is traveling through his body, and through the energy stick. So we have a closed circuit. If they take their two fingers away, we now have an open circuit and energy is not traveling through. Okay? Open and close. Now this is kind of interesting. You might like this. Keep holding. Put one finger into the water, not touching each other.
Yeah, be careful that you don't let your hands touch.
Why? What happens?
It'll change the experiment.
Okay, because water is a conductor of energy and electricity, we have a closed circuit. But if they touch the outside, the glass, take your fingers out and touch the outside of the glass. Glass is an insulator, and so energy is not carried. We have an open circuit. Here, you can wipe your fingers off, and thank you so much. You're going to have an opportunity later on in our activity part to try this and test it out with some insulators and conductors.
So we have the sun's energy and we're able to measure it. We have the air pressure, we have the water cycle, and now we're moving into something that's all around us, although we don't usually see it. Electricity.
Electricity.
Energy. Now sometimes that energy builds up real strong
And shocks you.
and it shoots across the air, and hopefully you're not near it to be shocked. We call it
Lightning.
lightning, right. And we have some lightning right here. Now we have some states of matter that we talk about, a lot. We talk about air, which is a gas, solid, which is like the table, doesn't move if you change it, or liquid, right, which takes the shape of its container. This state of matter is called,
What's the fourth state of matter?
it's going to be in here, it's going to be lightning, it's what it's all made out of. Starts
The
with
outer
PL.
surface of the sun, lightning, close. PL.
Does anybody know what this is called? What kind of ball is this?
Plasma.
Plasma ball. This is called a plasma ball because it is made of plasma.
And
Okay.
plasma is positive ions from electrons. Sorry.
And I need somebody who's not been up here. Do we have, or have we used everybody? Have you been up here? Come on around this side of the table. And I want you to just touch it with your fingertips. Why did that happen?
Your body's
Yes, his body is a conductor. It is attracted to him. Now, around this area, there is an energy field. And we're going to have him bring this light bulb into that energy field, just into it. You see what happens to the light bulb?
What is it doing? I don't know. I can't see it. It's lighting up.
Yeah, it's hard to see. The room is just a little bit too light.
Lighting.
But when we take it out of the energy field,
It's not lighting up.
it's going back to dark because there's no batteries, there's no plugs. It's just the energy field from here that is lighting it up.
I want to touch it.
Come to the museum. We have a big one here. All right.
Can someone put on you?
Thank you very much.
Now, there was a scientist who lived about the time of Thomas Edison. And his name was Nikolai Tesla. Now, he's not the scientist or inventor who is responsible for the Tesla car. But Nikolai Tesla, he wanted to study electricity, and he wanted to create electricity without wires. So he created the Tesla coil.
Do you use anything that doesn't have hooked to a cord that has to plug in? Wireless technology? Is there anything you can think of?
A light bulb? Phone?
What kind of phone?
Any kind of phone?
Not any kind.
Or a cell phone?
A cell phone, a tablet, an iPad, any of those things that do not have to be connected by a cord. That's the wireless technology that comes alive from Nikolai Tesla's work. He was born in Croatia. He's a wonderful person to read
The
about.
electricity stays inside of it.
Yes, it does. And he was considered a dangerous man back in the 30s when he was working.
And this is a Tesla coil, okay? And this shows you what electricity or lightning looks like, okay?
The color.
Look at the colors, as Miss Diane said. And it's the colors that it is because of the gas that's burning. This is about 80,000 volts of electricity. That's why Miss Diane and I are very careful when we use it. And we have a board between the stand and the table. A bolt of lightning is about how much? Any idea how many volts? Close, 1 million. About, what is it?
1 to 3 million.
1 to 3 million. So even though this is 80,000, it would still hurt us. So we have to be very careful.
All right, so we've talked now, we've added our electricity in our atmosphere. Now we're going to come to the wind. Air moving quickly. This is called an anemometer. Actually, it's very difficult to say because you stumble over it, but try it. Anemometer.
Anemometer.
And if you look up at the top, like at an airport or anywhere where they need to know wind velocity, you're going to see some form of this. But these will not always look alike. Where a radiometer will always have that black and white, these will not always look the same. People who are in boats have handheld anemometers. They have a little fan in them, and then there's computerized reading of how fast the wind speed is going. These are the original ones. How would they work? Any idea?
There's one different color because then you can tell how many times it goes around.
And literally somebody stood and counted it. Well, when the speed got to going that fast, do you think they were always accurate?
No.
No, probably not. So now they're computerized. Who would need to know wind speed? Sure, an airplane pilot needs to know coming in and taking off. A boat person, whether it's safe for their boat to be out.
Weather forecasters?
Absolutely, but who else? How about a semi-driver? Do they need to know wind speed?
Yeah.
Have you ever seen in those strong winds where the wind
Yeah.
whips down around a
Yeah.
bridge? And it can lift those semis up and move them. So the semi-drivers have to know when it's unsafe to be on the road. How about a race car driver? Yeah. They have to know how to balance out for those winds as they come around those curves. How about your moms and dads and your grandparents and anyone who's going on a trip? If you're driving into the wind, you're going to be using more gas If you're driving with the wind behind you, it's going to be helping you. So to judge how much you're going to be paying on that trip for gas or how often you need to stop. Absolutely, especially if they're up on a tall building, because there's some days it's not safe to be up there. So wind is an important part of our life, and these measure it.
Now, there's another scientist we'd like to talk about, and his name was Bernoulli. And Bernoulli lived hundreds of years ago. And he wanted to study air pressure. And what he discovered or shared or stated, his principle is that as we increase, it's known as the Bernoulli principle, as you increase the speed of air around an object, you decrease the pressure. So if you think of it, if this were an airplane, as we increase the speed of that airplane, you are decreasing the pressure under it and above it so that airplane can go up. And he had a direct impact on helping the Wright brothers to construct their first airplane. So a way to show you the Bernoulli principle, take a hairdryer and you increase the speed of the air, you are decreasing the pressure around it so it can stay in place.
Now it's a little bit easier to see with a bigger ball, but I'm going to warn you, if you don't like loud noises, cover your ears, because we're going to use a leaf blower. If you do like loud noises, just put your hand behind your ear, it'll make it even louder.
Yes.
But as the air goes across this surface, what did Miss Pat say? It's going to
Spin.
slow down. It's going to slow down, and so there'll be less pressure going off you. If I drop it right now, it's going to fall. Gravity's going to pull it down. But when we get the pressure underneath it, the air pressure, ball didn't want to stop. And that's what holds it up even when it comes way out there, is that air around it is controlling it. Now, if you have all these things come together, the sun's energy and the water cycle and the air pressure and the electricity and the wind speed, and they're all at tremendous levels, and they come together across land, what do we call that kind of storm?
A tornado.
A tornado. What if they're out over the ocean?
A hurricane.
A hurricane. Now we have something called a SciTech storm. Have you ever heard about it?
And there's some like they're inside the ocean. What are they called?
Oh, a tsunami? That's different. That's a wall of water that literally walks across the ocean. It starts from an earthquake, but it just kind of walks across. That's not what I'm talking about. This is a SciTech storm. And there's two rules to a SciTech storm. One is you must stay in your chairs. Number two is everything that comes out there must go in the garbage. Are you ready?
And if I may have the toilet paper, please.
Oh, sure. You guys push that.
Or,
We got shot.
okay. Thank you. Thank you.
How long does that do that again?
Now it's your turn to go to work.
Thank you.
We're going to go back to the tables, but before we do, turn your heads around and we'll explain what you're going to do back here. Starting with the energy stick. I don't even remember. Miss Paula will be back here at this table using the energy stick. You have a variety of materials here to choose from. One rule, do not touch these objects to this stick. It will eventually kill it, okay? So you put this in one hand, you put your object in a different hand. And everybody who's back here can make one big circle. You can make work together. The other thing you're gonna do at this table, and Miss Paula almost did it before, you put your dime on the edge of the table, you get underneath, and you puff the dime into the cup. Now, this is based on Bernoulli's principle of that air lifting it, making it move, and you can do it. We've seen lots of kids do it. Hands behind your back, no hands involved. Okay, over here, we've got several different kinds of materials. The first seem to work the best. You build up lots of static energy. Static energy is when you shuffle your feet across the carpet and then you touch your friend, and what happens? Shock. Okay, once you build up enough energy, there's string here, you can make it move and dance. You don't have to touch the bottle, you just bring it close and it'll make that metal dance, and it will also spin this. Okay, so just build up lots of energy and watch the fun. Over here you have your choice. There is a cloud recognizer, or a cloud wheel it's called, or a lightning calculator. Now with the lightning calculator, what you do is the lightning flashes and then you count 1,000, 2,000, 3,000, and you hear the thunder. So then you set this on a 3, because that's where you were, and it'll tell you how far away the lightning was. Now you put your name on it. This is yours to keep. Over here, you're going to make a paper airplane, and then we'll also have the bottle back here, which I forgot to bring. And you can throw these anywhere there's not people. After you make it, and then we'll make the cloud in the bottle. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 divided by 4, 3, and one person volunteers to be cut up, right? Yeah. Because we have a leftover.
I'll be left over.
Okay. No, we'll have one group of 4 and the other groups of 3. So 1, 2, 3, 4. Come to this table. And go ahead and start as soon as you get back there. 1, 2, 3, 4. Here. Oh no. One of you. Can I have you? You. Want to be the other group? All right. All right. 1, 2, and 1.
Start making circles out.
Yeah, 1 and 2. All right, put your name on your piece of paper. Well, make sure you keep that point at the top. You don't want to have a point. Then you turn it over and do the same thing and 3 times. So I have this. You turn it over and you do the same thing.
It's like a little more oil, but it's 3 times. So you hold that, and hold that. That was a great one. Okay, yes. What do you think on the CD? Think it's going to work? Think it's going to conduct electricity?
Now, when you hold it,
Why do you think it was gonna conduct electricity? Okay, but it has to be metal and that's plastic. Okay, this is a tricky one. Is this metal?
No.
It's made of aluminum, which is metal. Do you think this is gonna work? Okay, you hold that, hold that.
Nothing's working.
It works. Okay, how about, okay, before you both touch it, tell me if you think it's gonna work or not.
Yes.
Okay. What do you think about this?
Yes.
You think?
no, just one.
No.
Then we do the bottom up. There you go. Pretty cool. That's the Irish kick. Okay, touch your phone. Okay. See it scrolling up. Okay, did either of you want to?
Yeah, sure, I'll try it.
Ooh, wow.
That was pretty good. I found I was blowing the
Getting hard.
Okay, yes.
Okay, touch your phone.
Put your name on your wheel, and your scraps, put them in recycling.
Okay.
I got it in.
Make sure your name is on there.
It's not working. It almost goes. I got it. Now you can see.
There you go. Touch your
No one.
So essentially, this is you gotta get it way down underneath.
That'd be a point. There you go. Now you're gonna make that hole again.
I know.
Bring it back to the edge.
So you follow it, so that's why you need to
Really?
Okay. Okay, which one do you want to try, Zara? Okay, and which piece do you want to try? You want to try the flip-flop? Okay. You need 2 hands. It's not going to work. Okay. You think this will work? It's aluminum.
And that's what it's gonna look like.
You think it'll work? Okay. Now, okay. Here, you hang on to that. You hang on to that. Okay, you hang on to the other side. Okay. Now, the 2 of you hang on to the spoon. You hang on to that. You hang on to that.
This one's hard to do though. I think this one's the easiest for me. Yeah, not easy.
You touch the other side, you think it's gonna work?
I know when it is. Ready?
And now it's hard.
There's your cloud rolling out.
Someone catch it.
Okay, bend. Now bend the other side.
When you add more air into it, then it will stop and go down back and forth because you're cooling it down. Put your name on your paper.
So, you see the lightning. You count 1,001, 1,002. Then you hear the thunder. So move it to 2 seconds, and that will tell you that it is 2/5 of a mile away. Got it? What's your name on it? Throw your scraps away, please.
Okay, let's make your airplanes and then we can go back. Everybody needs a piece of paper. Here's my group. Take a piece of paper. So now, hold it not touch it.
That's the best way to probably close that side.
Are you sure? Then you take and one side, fold it in. Oh, that's right. Almost. Yeah. I think how would you even with the
Oh no! I blew it way away. I blew the thing. No, I just like you can get it. No, it's so small.
One end, you hold the other end, touch your hands. Yes, you do conduct electricity. Okay, you think this is going to, if you're holding it, this will complete the Let's try this one first, because this is the first thing you picked up. So you guys each hold one end of that. So, now let's bring another person in.
It's not.
You hold one end, you know. Come on back over here. Are you going to play with that? You want to try this? Okay.
That.
Hold that. Hold that.
You have to like try to sock it off.
You should do. You know why this won't conduct?
Something on the edge of something and you try to knock it off.
What is this made of? It's silver. Is it glass? Oh, you're touching your hands.
Well, that's get really hard. That means there's getting a lot of air in here.
I feel this thing warm.
And it's going to be really hot inside there. It's like shoving 1 million people into this room. Okay, are you ready? There's your cloud. Yep, it's rolling out the top. That's what we want to do. Okay.
Just mine. Yes.
Put your name on it so you're sure.
You need to hold it real hard.
Yep, 35
I have one, so I caught it.
Is it getting real hard? There's your cloud. All right, that's good. It rolled out the top. You made a good cloud. You can put your hand in it. Somebody else tried it. Do it again. It's just like a dampness. Okay, now you fold just one
Okay.
back to the other side. So you keep that point at the top. Well, it doesn't matter, because as long as you keep that point, I want to. Now you're going to fold it again, keeping that point by bringing this back to the edge.
Okay, it was 3 seconds.
It's got to keep that point by coming back to the edge. And then crease it into it one more time. Okay, one more time. One more time. Exactly the way you did it.
1 second.
What?
Now you're turning over your 3 folds on this side the same way. And make sure you keep your point up there.
It's pretty close.
And then go whisper
Is it just pure water?
You can use water.
Why do you think it'll work?
Coloring in the rubbing alcohol because it works faster. We can I think do a science experiment. We can do several kinds of
I found a new but I don't care.
Everybody's got to share in here.
I'm a ball.
You want to comment at the very end? That's how we're doing this on there. So, if you want to do
Okay, are you ready?
not bad. Somebody here needs to be part of this.
You're gonna make your own?
So you hold that.
Okay.
Okay. Touch hands. Okay, try to right now.
Okay. Tell me when it's starting to get hard. You want to punch There you go.
Don't do it. I still got my phone. You got it in. Good job. Did you want to try it again?